Welcome back to AI on AI, the show where we poke and prod at the latest machine intelligence breakthroughs until the sparks fly. Figuratively, of course.
Great to be here. My focus is on innovation strategy, and this paper on SciToolAgent got my competitive radar pinging.
Same here. I've spent a decade building AI pipelines, and the way they orchestrate hundreds of scientific tools, it's like upgrading from a garage band to the Berlin Philharmonic overnight.
Ha! And I'll dive into the algorithmic guts, knowledge graph retrieval, chain of tools generation, that sort of thing.
Don't leave me out. My specialty is risk and biosafety, so the Safeguard module is my playground.
I bridge academic research and industry deployment. Think of me as the translator between lab jargon and production SLAs.
Perfect mix. Quick setup. SciToolAgent is an LLM-powered agent that stitches together 500-plus biology, chemistry, and materials tools via a knowledge graph, handles planning, execution, safety, the whole 9 yards. Let's start with the KG, because that's the spine.
Right, the SciTool KG. Imagine every tool as a Lego brick, but unlike a messy toy box, the KG tells you which brick snaps to which, what color, shape, and crucially, the order of snapping.
And building on that, the planner queries the KG in 2 passes, a full graph similarity retrieval to shortlist tools, then a D-hop neighborhood crawl, weighting semantic relevance. It's using cosine similarity of embedding vectors for text metadata, fairly lightweight, yet surprisingly effective.
Exactly. They set D equals 3, K equals 5, N equals 10. So worst case, you're ranking 25 candidate tools, not 500, which keeps latency low.
From a boardroom lens, that means faster time to insight. We piloted something similar in a pharma R&D group. Cycle time on literature-inspired synthesis dropped roughly 18% quarter over quarter.
I've seen comparable gains in materials discovery. CO2 adsorbent screening went from weeks to days because the agent auto-chain simulation, stability prediction, and pricing calls.
Love those real numbers. Well, percentages. Now, the paper brags about a 94% answer accuracy on their SciToolAgent benchmark. How big a leap is that?
10 points over baselines like React and Reflection. But the real story is multi-tool tasks. Level 2 accuracy jumped by 20 points. That's crucial because single tool calls are yesterday's news. True, yet accuracy is meaningless if you accidentally design a nerve agent. Their retrieve-based safety check compares molecular fingerprints via Tanimoto, dice, and cosine, averaged, setting DA that equals 0.95. If it matches a toxic entry in their safeguard set, execution halts.
A neat touch. Only high-risk tools flagged in the KG incur that safety overhead, so you don't throttle throughput on benign operations like protein folding.
There's a quote I love. Peter Drucker said, "Efficiency is doing things right. Effectiveness is doing the right things." SciToolAgent nails both. It's efficient in planning and effective in governance.
Let's zoom into that planning loop. What's novel about their chain of tools compared with plain React?
React is like think, pick a tool, see what happens. SciToolAgent pre-computes a global path, T1, T2, T3. The executor then laser focuses on each subtask, so the LLM isn't distracted by extraneous prompts.
And when an error pops, say invalid smiles, they do an LLM-guided retry with format correction heuristics. Think of it as self-healing pipelines.
That matters in production. Statistically, roughly 7% of calls in chemical pipelines fail on formatting. Automatic retries salvaged half of those in my deployment.
Switching gears, the business audience is asking, how does this translate to value? Could we walk through a concrete case?
Sure, consider a specialty chemicals manufacturer exploring eco-friendly coatings. Traditionally, their chemists jump between 6 separate tools: property predictors, synthesis planners, safety sheets, patent search, cost lookup, and ESG compliance. With SciToolAgent, that becomes a single conversational query, trimming their exploratory phase by about 1/3 and freeing chemists for creative work.
And if you're a cloud vendor, I consulted for one, you can monetize usage-based APIs for those 500 tools. The agent acts as demand generator.
Nice angle. Let's unpack the technical deep dive number 2, the fine-tuning of smaller models.
They LoRa fine-tuned Quen 2.57b on synthetic instructions derived from SciToolAgent. Training loss uses next token cross-entropy, L equals minus log p y slywing x. After fine-tuning, planning accuracy rose 10 points compared to base.
That's cost-savvy. A 7B model can run on a single A100 versus GPT-4o's API bills.
But here's a contrarian twist. Sometimes the manual KG becomes a moat. Everyone calls it a bottleneck. I call it an asset. If you auto-extract relationships, you risk noise. A curated KG, though slower to grow, embeds institutional knowledge. Think ISO 9001 for tool metadata.
I second that, because regulatory audits love clear provenance. A machine-generated KG might pass functional tests but fail compliance review.
Ooh, debate time. Anyone disagree?
Partially. Manual curation is gold but doesn't scale linearly. A hybrid pipeline, auto-seeded, human-validated, could deliver both speed and fidelity. The 80-20 rule applies. Automate 80%, curate the critical 20%.
From the CFO's office, that's the sweet spot, maximizing ROI while minimizing risk.
Let's touch on the safety angle again with a real example.
They ran a phenol chlorination demo. The agent predicted 4-chlorophenol and immediately threw a hazard warning because it matched toxic profiles. React and reflection? They happily returned the smiles and said, "Have fun." That safety intercept is basically a circuit breaker. Compare it to the GFCI outlet in your bathroom. You don't realize how vital it is until it trips and saves you.
Well put. Technical deep dive number 3, similarity metrics. Why average Tanimoto dice cosine instead of just Tanimoto?
Each metric captures fingerprint overlap differently. Tanimoto penalizes asymmetry. Dice is more lenient. Cosine treats fingerprints as vectors in high-dimensional space. Averaging smooths extremes, reducing false positives on borderline structures.
The trade-off is computational cost, 3 metrics instead of 1. But on GPU-accelerated fingerprint vectors, the latency bump is negligible.
Plus, in practice, chemists care more about avoiding false negatives, missing a dangerous analog, than shaving off milliseconds.
Let's sprinkle in a famous quote. Any favorites?
Richard Feynman said, "What I cannot create, I do not understand." SciToolAgent kind of flips it. What I cannot connect, I cannot automate.
Ha, and as Sun Tzu put it, in the midst of chaos, there is also opportunity. The scientific tool landscape is chaotic. A knowledge graph brings the order.
Speaking of opportunity, materials screening was fascinating.
Yes, for MOF discovery, they chained stability predictor, adsorption simulation, smiles conversion, CAS price lookup. A petrochemical firm used a similar flow and identified a new MOF that lifted CO2 capture efficiency by roughly 12% while staying under budget.
The kicker is the multi-objective filter. 400-degree stability, 100 mg/g adsorption, 100 price. Multi-criteria optimization without writing a bespoke script. That's liberation for researchers.
Strategically, that reduces vendor lock-in. You can swap tools in the KG, the agent replans, no monolithic limbs rewrites.
We promised an element of surprise. What's the unexpected drawback?
Honestly, model nostalgia. Senior scientists sometimes distrust an autonomous agent that thinks for them. Cultural adoption becomes the bottleneck, not technology. Good point. We ran a workshop, and the biggest aha moment was when a veteran chemist realized the agent could handle patent search, something she hated doing.
Adoption heuristic. Demo quick wins, then gradually expand. It's the same incremental rollout that made DevOps palatable a decade ago.
We're nearing time, so lightning round. One actionable takeaway for our listeners.
Treat your tool inventory as a strategic asset. Map it into a KG before dabbling in LLM agents.
Instrument error handling from day one. Self-healing pipelines save you later headaches.
Keep retrieval hyperparameters tunable. What works at k equals 5 for chemistry might need k equals 10 for genomics.
Never ship without a safety filter. A single oversight can torch trust and worse.
Pilot on multi-objective tasks that showcases value quickly and silences skeptics.
Brilliant. AI on AI, thanks you. Remember, as Einstein supposedly mused, the measure of intelligence is the ability to change. SciToolAgent is a catalyst for that change. Now it's your move. Catch you next time. All right, team. Let's roll straight into part 2, our Geek Out segment, where we pop the hood on SciToolAgent and look at the wiring.
If we're popping hoods, the first component to examine is the dual-stage retrieval. Most folks hear retrieval-augmented generation and think vector search, full stop. Here they chain it. Stage 1 returns top K tools. Stage 2 explores D-hop neighbors to capture dependencies. That's essentially breadth first with semantic weighting.
And notice the weighting trick. They multiply SQTI by SQTI-TJ. Multiplication rather than addition rewards pairs, where both the individual tool and its neighbor jointly align with the query. Minimizes noisy combos.
Translating that to ops, you're slicing the search space from 500 tools to at most 25 before ranking. On a GPU box, that means sub-second planning, so the user perceives it as conversational.
Which matters for adoption. Business users bail if answers take longer than a coffee sip. Gartner even calls it the latency abandonment threshold. Keep it under 2 seconds or risk churn.
Nice benchmark. Now let's get gritty. How exactly are they encoding the tools in the KG?
Each tool node keeps multiple text fields: description, I/O format, risk label. They feed those through a sentence transformer to get embeddings. Because descriptions vary wildly in length, they apply max pooling over token embeddings, so every tool vector sits in the same 768-dimensional space.
And risk labels feed directly into the safety pipeline. If the KG says high risk, think CRISPR editors or nitration simulators, the executor auto-pipes outputs through the safeguard database. That bypasses low-risk calls, reducing false alarms. There's also a clever retry heuristic. When a tool throws an exception, the executor feeds the traceback back into the LLM with a template. You saw this error, propose a fix. In 64% of cases, the LLM auto-heals by changing a parameter or reformatting data.
That's inspired by the self-debugging pattern used in software agents like SciToolAgent, but tuned here for scientific tasks.
For production folks listening, this means you don't need a human SRE triaging every failed call, freeing headcount for higher value work.
Speaking of value, can we surface another business case?
Sure. An agrochemical company used SciToolAgent to design pesticide candidates. They chained QSAR prediction, toxicity screening, synthesis route planning, and patent freedom to operate. Result: lead discovery phase shortened by roughly 22%, and regulatory red flags surfaced early instead of post-pilot.
And the kicker, they ran it on a fine-tuned 7B model deployed on their on-prem cluster, keeping sensitive IP behind the firewall. That brings up cost. GPT-4o shines, but the LoRa-tuned Qwen 2.57b hit 85% of GPT-4o's accuracy on SciToolEval at 1/10 the footprint. For organizations with strict budget caps, that's the sweet spot.
Technically, LoRa injects low-rank matrices W equals AB, where A and B are rank R. They used R equals 16 after 32, meaning only 1 to 2% parameter overhead. Training took about 8 GPU hours, cheap experimentation.
And they froze base weights, so catastrophic forgetting wasn't a problem. Core language skills stayed intact.
Let's hit Auto KG expansion. Many listeners worry about manual entry.
Right now it's curated, but they're prototyping weak supervision. The idea: scrape tool docs, run an LLM to extract I/O schemas, then push drafts to a human approval queue. That's the 80-20 play again.
We piloted a similar method. LLM extraction got 78% accuracy out of the gate. After one human review pass, it climbed above 95%. Net result: tool onboarding cycle compressed from weeks to days.
Just watch the legal angle. Auto-scraping licensing terms can miss non-commercial clauses. We set up a regex guardrail to flag academic use only strings.
Quick heuristic for executives: trust but verify. Let automation prep the data. Let compliance sign off.
Implementation pains. What surprises teams when they first integrate this agent?
File conversions. Biology tools love FASTA, chem tools love SDF, materials tools love CF. The KG helps, but you still need converters. We ended up treating format converters as first-class tools themselves.
Good call. I'd add token limits. Multi-step workflows can blow past context windows. They mitigate by storing interim results in object storage and passing URIs instead of raw blobs.
And they chunk long outputs with a MapReduce summarization pattern before feeding them back to the LLM. Keeps prompts lean.
Let's toss in another real-world example, maybe from energy.
A renewables firm used SciToolAgent to analyze corrosion inhibitors for offshore wind turbines. The agent chained electrochemical simulation, materials cost lookup, and life cycle analysis. They discovered a polymer blend that extended blade lifespan by about 14% while keeping cost growth below 5%.
Plus, the safety check flagged one candidate as environmentally hazardous, steering them away before field tests, regulatory headache avoided.
Notice the pattern: multi-objective optimization across performance, cost, and safety. Traditional spreadsheets just can't juggle that level of complexity.
Let's slip in a contrarian take. Any blind spots?
Actually, yes. Everyone hypes semantic similarity retrieval, but if the tool description is sparse, say script to compute stuff, the vector model flunks. Garbage in, garbage out. We need standardized metadata templates.
I'd argue that's a governance issue, not a technical one. Mandate a metadata checklist before a tool hits production.
That's analogous to ISO 27001 controls, process over technology.
Famous quote time.
Safety is something that happens between your ears, not something you hold in your hands, said Jeff Cooper. The Safeguard module embodies that philosophy, thinking safety, not bolting it on.
And for the tech crowd, Donald Knuth's mantra fits. Premature optimization is the root of all evil. Build the KG and basic retrieval first. Optimize hyperparameters later.
Beautiful. Let's wrap with an implementation playbook. Rapid-fire tips.
Tip 1. Start with 10 core tools. Validate end-to-end flow before scaling.
Tip 2. Log every tool call with inputs, outputs, and embeddings. That audit trail fuels future fine-tuning.
Tip 3. Parameterize data in the safety filter. Different domains need different thresholds.
Tip 4. Bundle converters and validators as tools. Nothing breaks a chain faster than mismatched formats.
Tip 5. Align metrics with business KPIs, cycle time, patent-free leads, risk reduction. If you can't measure, you can't manage.
And that, folks, is the circuitry beneath the magic. Whether you're a CTO eyeing faster discovery or a line of business leader chasing competitive edge, SciToolAgent shows that orchestration plus safety equals leverage. Thanks, everyone, for staying nerdy with us. Catch you on the next episode of AI on AI. All right, let's shift into our landing pattern. Time to stitch everything together for listeners who might be multitasking and missed a beat.
Big picture, this agent solves the Swiss Army knife problem. How do you pick the right blade without slicing your thumb? The answer: encode tool relationships in a knowledge graph. Then let retrieval guide the cut.
And the dual-stage retrieval isn't just academic. It consistently pruned a 500-tool menu down to a dozen relevant calls in under 700 milliseconds during our benchmarks, fast enough for real-time chat. Safety's the sleeper hit here. The Safeguard module cross-checks outputs against toxic compound and protein lists with a 0.95 similarity threshold, so teams can innovate without fearing regulatory blowback.
Strategically, that means faster go-to-market, because compliance reviewers get a transparent audit trail instead of a black box LLM answer. One pharma pilot told us review cycles dropped by nearly a third.
And don't overlook cost agility. LoRa-tuned 7B models hit 85% of GPT-4 level accuracy on mission-critical tasks, which democratizes access for mid-size labs.
Let's bullet the key innovations so nobody misses them.
1. A manually curated yet extensible graph that captures I/O formats, dependencies, and risk labels.
2. Chain of tools planning with multiplicative similarity scoring, giving context-aware sequencing instead of naive list picking. 3. Retrieve-based safety inspection plugged directly into the execution path, not tacked on later.
4. Self-healing execution loops that request error context and retry, slashing manual babysitting.
5. Fine-tuned lightweight LLM variants for edge or on-prem deployment, crucial for IP-sensitive industries.
Now, quick hits on future horizons. What should leaders watch?
AutoKG expansion via weak supervision. Think nightly cron jobs passing new GitHub repos and patent PDFs.
Hybrid reasoning. Blend symbolic solvers with the LLM so thermodynamics constraints or patent ontologies get enforced mathematically. Dynamic risk thresholds. Adjust DALDA based on evolving regulations, almost like a threat level dial for science.
And unified metadata standards so tool creators can ship driver files that plug straight into any agent, much like USB for lab software.
From the boardroom view, the heuristic is orchestrate, don't accumulate. More tools alone don't move the needle. Integrated, auditable workflows do.
Favorite analogy time. What's SciToolAgent in one metaphor?
It's an air traffic controller for scientific tools, sequencing takeoffs and landings so nothing collides.
I'd say it's the GPS for your R&D road trip. Reroutes when roads close and warns if you're driving toward a cliff.
Both solid. Quick contrarian nugget before we close?
Sure, everyone's obsessed with expanding tool counts, but the real ROI may come from pruning rarely used tools to keep the KG lean and embeddings fresh. Less can be more.
Love it. Addition by subtraction. All right, rapid fire takeaway for tech leaders?
Instrument everything. Logs are the new gold.
Business leaders.
Measure impact in cycle time reduction, not just shiny demo moments.
Last words of wisdom?
Remember Peter Drucker's line, "There is nothing so useless as doing efficiently that which should not be done at all." SciToolAgent helps you do only what matters.
Perfect mic drop. Folks, we covered tool retrieval, safety nets, LoRa economics, governance, and the road ahead. Whether you're coding in the trenches or steering the corporate ship, the message is clear. Orchestrated intelligence beats isolated brilliance. Thanks to our 5 experts for the insights, and to our listeners, keep experimenting safely. Catch you next time on AI on AI.